Alright, welcome back to Fun Further Maths. I hope everyone is well and ready to finish off Chapter 8. Yes, last exercise from Chapter number 8. We are powering along. 8G, awesome. This is looking at nominal and effective interest rates. And kind of have touched on this in the fun booklet chats, but this is going to hopefully clear things up a little bit. Yeah, this is pretty interesting. So it says here, if we're talking about a nominal interest rate, it says compounding interest rates are usually quoted as annual rates, so that, or interest rates per annum. So it'll have like it's 6% PA or per annum for the whole year or annually. Yep. When it's talking about the whole year, that's what we call a nominal interest rate. Yep. Whether it's for an investment or for a loan. However, sometimes an annual rate might be quoted. So they might tell you, okay, yeah, it's going to be 6% per annum for your loan. But then they can actually say, well, we're going to compound, or they're going to charge the interest at a different type of time period. Yep. So they go, we're going to give this interest rate, but the interest can be also calculated, monthly, for example. The time period after which compounding interest is calculated and paid is called the compounding period. Cool. So you need to read the questions carefully and actually look at how often the interest rate and what the compounding period actually is. And so I kind of did joke about this the other day with the fun booklet, but you do need to know some basic fun facts with your with how things work in terms of days of the week and how calendars and things work. Yep. So you do need to know that there are 12 months in every year. Yep. So make sure you're aware of that. You need to know that there are 4 quarters in every year. Yep. And when a year is divided into the 4 quarters, each quarter is 3 months in length because there are 12 months in a year. Yep. Another thing is you do need to know that there are 52 weeks in a year. Yep. And if we're talking about fortnights, not the video game Fortnite, guys, we're talking about the time fortnights. If there are 52 weeks in a year, a fortnight's 2 weeks, so it's half of 52, which is there's 26 fortnights. Yep. Also, you do need to know that there's 365 days in a year. Don't have your brains exploding going, oh, what about leap years and all that? You ignore the existence of leap years. Yep, further maths, we don't even acknowledge that leap years exist. Even though they do, not for the calculations. Yep. It says a nominal interest rate is converted to the compounding interest rate by dividing by these numbers. Yes, you have to read the question carefully, look at what it is, and you are dividing by how many there are in a year. Yep. So let's have a look here at some examples. It says an investment account will pay an interest rate of 3.6% per annum. So over the whole year, you're going to get paid 3.6%. Yep. It says convert this interest rate into each of the following. Cool. So it's saying 3.6% per annum. Let's see what the monthly rate is. Well, this is where you need to go, well, how many months are there in a year? I remember learning that a little while ago, or I remember Mr. Failing saying that earlier in this video. There's 12 months in a year. Yep. So what you need to do is divide that interest rate, 3.6, by 12. In this case, it comes out to being 0.3%. Yep. So that's the monthly rate. No surprises here. If you're asked to calculate the fortnightly rate, we just said there were 26 fortnights in a year. You have to divide that by 26, which comes out to that. Lastly, a quarterly rate. There's 4 quarters in a year. You have to divide that value by 4, which gives us that as a percentage there. Cool. Pretty easy calculation as long as you get the right number for each of those and you know your basic days of the week, etc. Alrighty. The next thing we need to have the chat about is what's called the effective interest rate. Yep. So what you need to know that with compounding interest, the more often interest is calculated or added to your investment or loan, the more rapidly the value of your investment or loan increases. Yep. So we'll have a look at this table in a moment, which is on page number 293 of your fun booklet, your fun textbook. Basically, it's showing, okay, what happens if we have $5,000 invested and we pay 4.8% per annum? What happens to the amount we get depending on whether we are paying the interest quarterly, monthly, rather than just yearly? Yep. So we'll have a look at first what happens yearly, or if it's compounded on each of these other things. Yep. So, here's the fun table. Cool. So here's your $5,000 that's invested. It's at 4.8% per year. Yep. So if you're doing that for the whole year, you had $5,000. You wanted to calculate what the 4.8% is of the $5,000. Cool. You'll work out that it's $240 that gets added on. You're earning $240 interest for the year. Yep. Obviously there are 12 months in the year, so it's happening yearly. Cool. The effective annual interest rate in this particular case is 4.8%. Here, if we decide to do it quarterly, remember you have to do this 4.8%. You are dividing that by 4, so it's 1.2% that's happening each quarter. So after every 3 months, you're going to be working at 1.2%, and you're getting that amount added on. Yep, and because it's happening more regularly, here you've now got the $60 added on after 3 months. The next interest part gets calculated on this figure, which is slightly bigger. Yep. So by doing it more regularly, you can see here that after the year, because you've been paying the interest, it's been compounding more regularly. You have a larger amount that's been earned in interest. Yep. And look at this. Whoa! If you do it monthly, so even more regularly, so 12 times in the year, you can see here the calculations take place. You end up with even more interest earned than each of these other particular cases. Yep. So when we talk about effective annual interest rates, or effective interest rates, what it's saying is, okay, if it's 4.8% per annum, yep, you're going to get the $240. But in reality, if you do this compounding more often, it's not exactly 4.8 that you're going to get. You're going to get more, a real effective value that's higher the more often you have your values compounding. So there is a way to calculate the effective rate. Yep. So if it was compounding yearly, obviously they earned $240 interest on the $5,000 that was invested. So you do the 240, which was the amount that was earned as interest, divided by the initial amount, multiplied by 100. It's 4.8%. There's no surprises there. With the quarterly, where it happened 4 times a year, again, you would do the interest earned, which in this case is $244.35, divided by the initial amount, which was $5,000, multiply that by 100, and it comes out to being 4.89% per annum. Yep. So it's actually, if you think about it as a per annum value, by doing it compounding quarterly, you can see it's higher interest rate that you actually are getting. Yep. And doing the same thing for monthly, here's the amount of interest that was earned. Divided that by 5,000, which was the initial amount, multiplied by 100 to change the percentage. It comes out to being an effective rate of 4.91%. Yep. So both of these are clearly higher than the 4.8% per annum by doing the compounding interest more regularly. Yep. You could write out a table, yep, like we just went through that example. It's time consuming. I can see eyes rolling back in heads as I'm saying that, yep, we don't want to write out a table. Good news is you don't have to. There is actually a formula that we can use to calculate the effective interest rate. Yep. So, it says here the effective interest rate of a loan or investment is the interest earned after 1 year expressed as a percentage of the amount borrowed or invested. Cool, we were cool with that. It says let R be the nominal interest rate per annum. So remember when we talked about nominal interest rate, that's just the one that's the calculated over the whole year or per annum. And they're saying let R effective, with little subscript there, R effective be the effective annual interest rate. So they are different things. And let N be the number of times the interest compounds each year. Cool, that's easy to work out. So to actually calculate the effective annual interest rate, we use this formula. It's calculated. The R effective rate can be calculated by 1 plus little r, so the nominal interest rate divided by the number of times the interest compounds over the year, so r over n, and that is divided by 100. Notice all of that is then raised to the power of n. Then we take away 1, and then we multiply by 100. You will need to practice entering this into your calculator carefully. I even also recommend starting to put brackets around like this part here, which is the fraction on top of the fraction. Sometimes on your calculator as well, there's like little fraction templates, which is like a little square and a line and a little square. If you're using the fraction templates, obviously this fraction needs to be on the top of the fraction template, and so forth and so forth. Please get used to typing this in correctly and check that you are getting the right answers. Brackets in the right spots helps as well. Yep. It's easy to plug the values in, but it's the calculator and the brackets and typing it in correctly that causes problems. Yep. So let's actually look at how you would go about doing this. Oh, it's Brooke. She wants to borrow $20,000. Yep. And she's decided she has to decide between two loan options. Yep. So they're presenting Brooke with these two options. She needs to decide which is the better investment. Yep. So option A, they're telling her that she can get 5.95% per annum compounding weekly. Yep. Alrighty. So again, that's what it is per year, but there is a compounding part where it's compounding weekly, not compounding annually. Yep. This one here is 6% per annum, and it's compounding quarterly. Cool. Now, some people are very tempted to just go, oh, 6% is higher than 5.9%. Obviously, this one's, they would say, oh, this is a larger number, so it's better. Because when you're earning interest on a loan, you're wanting to get the higher interest rate, so you're earning more money. But because there are different compounding time frames, you actually need to convert each of these to the effective interest rate to be able to compare them. I think this is a classic being able to compare apples to apples. Yep, you can't compare apples to, what's another fruit? Grapefruit. Or bananas, probably. Whatever, yep. You can't compare them. So let's do the calculation of the effective interest rate for each option to start off with. Yep. Option A was 5.95% per annum, so that's the R value. It's compounding weekly, so you need to know there are 52 weeks in a year, so the N value is 52. You need to carefully plug those two values into the formula that I've just spoke about. So little r, the rate over n, and there's another to the power of n. Again, sometimes I reckon on your calculator you have to close this. I do a bracket after the 52 and another bracket in here, because if you're not careful, some people put this take away 1 in the power bit up here and do 52 take away 1 in the power, which is like putting it to the power of 51, which is not what you want. Yep, so please be careful with this calculator. Actually, if you type this in, you really should be getting 6.13. Yep. So if you type this in and it doesn't come out at 6.13, you know you're not typing it in correctly. So just play with that. So the effective interest rate here is 6.13. Cool. Let's change this one to its effective interest rate, 6% per annum compounding quarterly. Quarterly means 4 times a year. Yep. So the N value is 4. The rate is 6. Plug it into this formula for effective interest rate, and it comes out to being 6.14%. Cool. All right, they are close, but if you want to invest money, you want to be getting the higher interest rate. And out of those two, the higher effective interest rate is the 6.14%. Yep. So in this particular case, oh, sorry, she wants to borrow money. Well, I was reading it wrong. Sorry, I thought she was investing the money. She's borrowing the money. When you're borrowing the money, you want to be paying the lower interest rate. Ooh, I nearly got that wrong. So when you're borrowing money, you don't want to be paying as high interest rate. because it's going to cost you more money. So in this case, sorry, the 6.13% is the better option for Brooke because she's paying a less interest rate. So option A. And you can see here, option A, yeah, it is 5.9% per annum compounding weekly. But now we can see what its effective rate is. Yep, so it's lower. So Brooke is borrowing money, so the best option is the one with the lowest effective interest rate. So she'll pay less with option A. Cool. Oh, sorry about the confusion there. Hey, there's a fun bubble box. It says here, for any, remember, watch out. It says for any compounding interest, loan or investment, increasing the number of compounds per year will increase the total interest earned or paid. Yep, so the more there are, the more interest is earned or you have to pay. Cool. Next one is a calculator task. Yep. So sorry, we'll read here. This is it's Marissa. She has $10,000 to invest. Okay, this one she's investing. Okay, and she's choosing an account that will earn compounding interest rate at 4.5% per annum, which is compounding monthly. It says use CAS calculator to find the effective rate for this investment correct to 3 decimal places. Alrighty, what you need to know for compounding. The effective interest rate with your CAS calculator is what the interest rate is per annum, so the nominal interest rate, and then how many times per year it happens. So in this case, it's compounding monthly. And the end value is obviously 12 in this particular case. So R is 4.5, N is 12. You can go to your calculator, and there's a cool conversion for effective interest rate, and you have to get to it by going action, financial, interest conversion, conf F. That's obviously for conversion to effective interest rate. Yep. Once you load that up, the first value you enter after the function loads up is the end value. So how many compounds it happens per year. In this case, there is 12. Yep. After that, you press the comma and you say what the nominal rate is. It's 4.5%. Yep. So you put the 4.5% in, close the brackets, run it, and it will spit out what the effective interest rate is, which in this case is 4.594. Cool. Thank you very much for listening up. You do have a bit of fun, a few fun questions to go on with in exercise 8G. Hope you're enjoying this chapter, which is just about over. That's it from me. Bye for now.